In this section, we're going to talk about functions and relations. Let's talk about relations first. Many quantities in life are related to each other, such as mailing cost and the weight of the package, or test score and the number of hours of study. In math, we define a relation as a set of order pairs xy, where x and y are quantities that are related to each other somehow. A set of x values is called the domain, and a set of y values is called the range. Let's look at this example. Given the following relation, now a reminder that we only use the curly brackets for set notation. So in this set, there are 5 order pairs, 1, 2, 3, 4, and 5. And the question here is we need to list the domain. The domain is just all the x values. So we're going to list all the x values that you see. X values is always the first value in an order pair. So we have 3, 2, -4, -1, and 3 again. But since we already wrote down 3, we don't have to write it again. Only write the unique values. Range. Let's write down all the second values that you see in the order pairs. So we have 1, 5, 2, 0, and -4. Ideally, we can write them in order of the numbers from the smallest to the biggest, for example. Now let's talk about function. By definition, given a relation in x and y, we say that y is a function of x if for each value of x in the domain, there is exactly one value of y in the range. What it means is no two order pairs may have the same x coordinate and different y coordinates at the same time. So let's look at these two examples. So the first relation, we have the x values are 1, 2, and -2, and the y values are 1 and 4. We can go ahead and list the order pairs. So each arrow here represents the correspondence between x and y. So the first correspondence represent one order pair. So we have 1, 1 as the first order pair. Second order pair is 2, 4. And third order pair is -2, also 4, because the two arrows both point at 4. Now looking at all these order pairs here, we can see that all the x coordinates are different. All of them are different. Therefore, it is a function because it has no two order pairs that have the same x coordinate and different y coordinate at the same time. All right, let's look at this example over here. The order pairs are 1, 3, 1, -1, 2, 2, and 5, 4. Now this one is not a function because of these two order pairs here. They have the same x coordinate, which is 1, but at the same time, in those order pairs, there are two different y coordinates, which goes against the definition of a function. So the answer for the first one is yes, it is a function, and the answer for the second one is no. If there is a graph of a function presented, we can use something called the vertical line test to determine if the graph given is the graph of a function or not. Here's how the test works. The graph of a relation defines y as a function of x if no vertical line intersects the graph in more than one point. Let's look at these two examples. So the first graph, here's the first graph. We want to see if it is a function. Based on the vertical line test, it means that when you draw any vertical line, it can only intersect the graph at one point at most. There can be no vertical line intersects the graph in more than one point. So What if we draw a vertical line here? As you can see, it doesn't even cross the graph, but it has to be true for any vertical line test. So we're going to draw another vertical line here. With this one, as you can see, this vertical line intersects the blue graph at 2 points, which violate the vertical line test. Remember, no vertical line can intersect the graph in more than 1 point, and this vertical line intersects at 2 points, so it is not a function. In the second graph, doesn't matter what vertical line that you draw, each time the vertical line only intersects the graph at 1 point at the most. Let's draw another vertical line. It only intersects at this point, just 1 point at a time. And therefore, it passes the vertical line test. So this is indeed a function.